Okay, today class we want to talk about the properties of tangents. The first property of tangency says if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. Okay, this is what they're saying. If you have this line that is tangent, okay, to this circle, it touches right here. Then if you have a radius drawn to that point of tangency, then it's telling you that this makes a right angle. And you will always know that that's a right angle. Okay, so there's another tangency theorem, and it says in a plane, if the line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. Okay, so in this case, the first theorem says if you have a tangency line and that's and the radius is perpendicular, then you know this is a right angle. If you know this is a tangent line and you know this is a radius, then you know this is a right angle. Okay, theorem 2 changes that around. Theorem 2 says this: if you have a line that appears to be tangent and you have a radius, then if you know this is tangent and you know this is the radius, well, you do know this is tangent. This theorem saying you know that this line is tangent if you see a right angle. Okay, so if you don't see a right angle, but you know this is tangent and you know this is a radius, then you know there's a right angle there. But on this one, if you see a right angle, then you know this line is tangent. Okay, so let's use that idea that a tangent line and a radius, when they intersect, they form a right angle. Let's use that idea to work this problem. It says AC, this ray AC, is tangent to circle B at point C. And so it says find BC. So right here's what we're trying to find. So let's call that X. Okay, so what do we know about this triangle that's produced here? We know that this is the radius. We know that this whole length here is 13, and we know this length right here, AC, is 12. So we know also, though, if this is the radius and it connects to the tangent line, we know automatically that that is a right angle, and we can write in that right angle. So it makes a right triangle. Okay, so if you've got a right triangle and you're missing a side, what did you use previously in geometry to find a missing side of a right triangle? That's right, use the Pythagorean theorem. You used c squared is equal to a squared plus b squared, where the 12 and the x are your a and b, and 13 is your c. Okay, so let's fill this in. So 13 squared is equal to 12 squared plus x squared. So 169 equals 144 plus x squared. So you subtract 144 from both sides, and you end up with 25 equals x squared. And don't forget, I don't want to know what x squared is. I want to know just what x is. So you square root both, and you get x equals 5. Okay, pretty easy. So there is a reason that we need to know this rule, because if we make a right angle could also be a right triangle. Okay, let's see what else we can do. Okay, example 2 says here, if you are standing at C, right here, and it's 8 feet from the silos, that just means this distance right here is 8 feet from C to the silo is 8 feet. So you don't know the whole distance like you did in the other right triangle. The distance to the point of tangency is 16 feet. So C to B, B is where it touches, where it's tangent, is 16 feet. What is the radius of the silo? Okay, so this is your radius and this is your radius. Again, you have a right triangle, so we're going to use the Pythagorean theorem. So we have C squared is equal to A squared plus B squared. Okay, so, and we want to say our A is equal to 16. Let's say our B is equal to R. And note that our C is equal to R plus 8. Because the whole length is not 8, this section is R, and this section is 8. So if you want to know what that whole line is, you add them together. Okay? All right, so we need to fill these in. So we have R plus 8 squared equals 16 squared plus R squared. Okay, this is a good problem because this reminds you of your Algebra 1 when R plus 8 squared is the same thing as R plus 8 times R plus 8. And remember, we just did the Pythagorean theorem. I'm sorry, we did the, we did R times R and R times 8, 8 times R and 8 times 8. We did the full method, okay? Or the distributive property twice. I just couldn't think. Okay, so R times R is R squared. R times 8 is 8R. 8 times R is another 8R. And 8 times 8 is 64. Okay, now when we squared 16, we get 256. And then R squared, of course, is R squared. So this is equal to 256 plus R squared. Okay, so the first thing we need to do is let's put our R's together. So we have R squared plus 16R plus 64 is equal to 256 plus R squared. Now let's get our R squares on the same side together. So to do that, I think what I want to do is subtract off R squared from both sides, but look what happens. That cancels. Okay, so now we have 16R plus 64 is equal to 256. All right, looks a little tricky, but it's really not. This is just a two-step problem. They're adding 64, so let's subtract 64. Okay, so you're right. You have 16R is equal to 192, and you divide by 16, and you get R is equal to 12. Okay, so you found the radius. All right, so let's think about this one more time. This is using just the Pythagorean theorem. This will be your A part. This will be your B part. And of course, your C is going to be these two put together. Okay, so it had to be R plus 8. So you have to put its segment addition property. All right. All right, so now that we've done that, let's see if you can answer this question. It says, how can you show that EF must be tangent to D? So what must be true about this triangle if this line EF is tangent to this circle right here, to circle D? Well, it must be a right angle. So how could we know if this is a right angle? How would we know if this is a right angle? Okay, well, we could use the Pythagorean theorem. Well, Miss Wright, you're not missing anything. You're right, I'm not missing anything, but I need to know, is C squared equal to A squared plus B squared? Because if it is, then this is a right triangle. Remember, if it's greater than, this would be an obtuse triangle. And if it's less than, this would be an acute triangle. Okay, so again, across from my right angle is my C. Here's my A, and we'll call 9B. So we have 15 squared is equal to 12 squared plus 9 squared. Now I'm going to pause and let you finish this. Okay, so since 15 squared is 225, and 12 squared is 144, and 9 squared is 81, 144 plus 81 is 225. So since 225 is equal to 225, then, yes, EF is tangent to circle D. Okay, now let's go to the next example. All right, from what we understand so far then, if I tell you that ED is tangent to circle P, and from P to D has to be a radius because D all the way down to here is a diameter, then what do you know about this angle right here? You're right, it's what we just learned. This is a right angle. All right, if that's a right angle and I have a triangle here, how can I find a missing angle? What do you know about three angles in a triangle? You're right. Three angles in a triangle add up to be 180 degrees. So, x plus 90 plus 38 is equal to 180 degrees. Now I want you to pause and finish this. Okay, did you get that 90 plus 38 is 128? And then when you subtract 128 from 180, you get x is 52. So not only can you find sides of a right triangle, you can also find the inside angles of a right triangle. All right, now let's talk about tangent segment. It touches a circle at one of the segment's endpoints and lies in the line that is tangent to the circle at that point. So this is your tangent segment. All right, so what we want to learn about a tangent segment is we want to learn that in this problem right here, since we just got through talking about angles, what do we know when the tangent segment joins and meets the radius, and the tangent segment here joins and meets the radius? You're right. You have right angles again. And what do you know about a four-sided figure? Yes, it's equal to 360. So I've got x plus 90 plus 90 plus 117 equals 360. I'm going to pause and let you finish this problem. Okay, so did you get 63 as your answer? Good. All right, there is one more theorem that we need to talk about, the tangency theorem 3. It says if two segments from the same point outside of a circle are tangent to the circle, then they are congruent. And that's what we're showing here in this picture, that these two tangents lines are always congruent to each other. All right, so if we know that they're congruent to each other, then what would you know if I said that TS, this tangent line right here, is tangent to circle P, and that RS is tangent to circle P? So it says find x. What that means, what do you know then about 2x plus 3 and 11? You know that they're congruent. All right, so it would be 2x plus 3 is equal to 11. Now I know you can solve that problem, so we're going to pause and solve. Now you can see how easy it is just by knowing that it makes right angles and that these two tangent lines are congruent to each other. You know how it is to solve how easy it is to solve problems. That's the end of the lesson.